Assalamualaikum and hello everyone. Welcome to the last video of chapter 2, which is 2.3 learning computation. And in this video, what we're going to do is actually I'm going to answer some of the examples. But the examples are combined question, basically what we have learned in 2.2 and 2.3. Okay, so now let's look for examples on page 22. Okay, so the first example here, kita dekat sini, here number 1. The proton number of an element A is 12. So, write the electronic configuration of element A. So, when they ask for the electronic configuration, it could be in two terms, be it as PDF notation, or you could write it down in terms of orbital diagram tu lah, yang 1s, 2s, and then you're going to fill up the electron itself. Okay, kali ni Miss nak buat through SPDF notation. So, when element is 12, element A is 12, so it will be 1s2, 2s2, 6, so total is only 10, so kita tambah lagi jadi 3s2. Okay, so that's for question A. Question B. Draw the shapes of orbital occupied by the valence electron. So the valence electron, it means that it is the outermost electron. Outermost electron. The electron which is the furthest away from the nucleus. Ataupun senang nak kata hanya the highest principal quantum number lah. So dalam kes ni, the highest principal quantum number kita is actually n equal to 3. So draw the shape of orbital. Shapes tu kita ada S, E, D. Kita dah belajar kan, spherical shape, double shape, cloverleaf shape. So dalam kes ni, when n equal to 3, we only have S orbital. So what I'm going to draw, in this case kita akan draw S orbital lah. Okay, so for the drawing itself, you must have your axis. So tak kisahlah macam tu x1 seg, but for the s orbitals, it is spherical shape, and you must shade the orbital itself. Last but not least, you have to label it is actually our 3s orbital. 3s, you have to label yang n juga, sebab dia nak valence electron. If you only write down s, it could be 2s boleh, 1s pun boleh. So you must be specific. Is 3s. So in this case, sebab dia ada 3s sahaja, so we're going to draw 3s orbital only. Called the 3p, we have to draw 3p as well lah. So that's for question B. And now let's look for question C. Give the sets of quantum numbers for the valence electron. Again, valence electron is the outermost electron, which is the electron with the highest n. Okay, so quantum number, if you still remember, nasi lemak memang sedap ataupun nasi lemak masak sambal, masak sotong. Nasi NLMS. Okay. So, N kita is actually N is equal to 3. Okay. So, L kita is equal to 0. Okay. Remember, when L equal to 0, it's actually S orbital. L equal to 1, dia adalah P orbital. L equal to 2, dia adalah D orbital. Okay. And then, what is your M? So, when L equal to 0, M kita memang ada satu sahaja possibility. So, L kita is actually 0. Okay. So, remember, okay, if you be unsure, kenapa M kena 0? Bukan 1, 2 ataupun 3. Okay, kita tengok balik. Here, which is on your page 13 punya notes. Okay, when L equal to 0, M could only be 0. So, memang ada satu sahaja ni lah. Kalau L equal to 1, dia boleh negative 1, 0, positive 1, and so on. Kalau 2 ni, ada negative 2 until positive 2 punya value. Okay, sebab tadi L equal to 0, hence M must be equal to 0. Okay, so kita balik pada nota kita. Oh, ni, Okay, so, dekat sini, that's why lah M equal to 0. S could only be positive half ataupun negative half. Positive outward spin, negative yang downward spin tu lah. So dekat sini, kena write down positive half. Okay, but then the question give the sets of quantum numbers. So we're going to give semua possible lah. So we do have 2 electrons kan. So write down lah. Ataupun, or, dia akan jadi 3, 0, 0, negative half. Okay, so that's for question C. Question D, predict the stable oxidation number of element A. Explain. Okay, so oxidation number ni, it could be Miss bagi hint So contohnya, kalau selalunya yang kamu familiar kan, kalau kamu tahu chlorine, oxidation number dia -1. Kalau apa ni, copper, oxidation number dia yang famous dia +2. Macam tu lah. Okay. So, oxidation number ni, so maknanya dia ada dua pilihan. It could be positive or it could be negative. Okay, so kalau positif ni, what does it mean is that it will lose the electron. Tapi kalau dia negatif, dia akan gain electron. Okay, so kenapa dia nak lose ataupun gain electron itself ni? Sebab actually they want to lose ataupun gain electron ni to help the atom to achieve octet. Achieve octet arrangement. Octet arrangement tu it means that the outermost electron tu kena ada 8 octet. 8 Okay. So in this case, so kalau macam tu, if you be unsure kan, kita tengok yang ni. Okay, so yang element A ni I'm gonna write down in terms of our yang SPM dulu kita belajar. Which is, kita kalau SPM dulu, kita tahu ni adalah 2.8.2. Sebab first shell ada 2 elektron, second shell ada 6 ada 8 elektron, third shell ada 2 elektron. Okay, so we know the element ni dia akan donate electron ataupun gain electron to achieve octet. So the outermost electron is actually 2, and we know that the electron wants to achieve octet configuration. So octet arrangement ni, it means that it wants the last electron to the outermost electron or the valence electron must have 8 electron itself. So for this case, as we can see, the outermost dia 2 electron. So it could lose 2 of its electron ataupun dia boleh gain 6 electron. Okay, which one yang kita akan ambil? Kita akan ambil the smallest number lah, yang 2 ke 6 ni itself. So we're going to take 2. Okay, so bila 2 ni, again, we want to donate the 2 electrons. Okay, so bila donate ataupun lose electron, we're going to take it as positive. Tak naklah lose ni kita letak donate Donate or lose electron. Okay, so again, what we want is that we will donate the 2 electrons itself. So kita tahu the number would be 2, but is it positive or negative? Dia akan jadi positive because we're going to donate our electron. So we're going to write down positive 2. So contohnya sini dia akan jadi positive 2. Okay, why is it positive 2? We're going to explain. Because 2 electrons are donated to achieve octet. Okay. Octet, kita tambah lagi arrangement. Okay, so again, for the case of the stable oxidation number, actually the electrons tu want to achieve octet arrangement. So, based on the number itself, tengoklah you want to donate ke you want to lose. Number tu tengok number mana lebih kecil. Donate ke lose tu, make sure donate positive. Kalau gain electron, it will be negatively charged. Okay, so again, the act of donate ataupun gain electron tu is actually to help the atom itself to achieve octet. Okay, so for question number 2, okay, yang question number 2 ni, Miss tolong sikit je. So element B, so element B is 9, so 9B, so kita tahu 1s2, 2s2, 2p, 5, betul tak? Okay, so 2 plus 7 is 9. So this is actually the electronic configuration. Next is actually draw the shape of orbital occupied by the valence electron. Again, valence ni, it means that it is Nina. Outermost electron, which is the highest n. So highest n kita dalam case ni is n equal to 2. Tapi tadi kita tengok when n is equal to 2 is only 3s orbital. But this case around, we have s dengan p. Okay. So what I'm going to do is actually we're not only going to draw the s orbital. So highest n kita, again, highest n kita when n equal to 2, we have our s and p orbital. So we have to draw s dengan p lah. Okay, so I'm going to draw again yang ini. Just copy paste je. Okay, so tapi dalam case ni, what I'm going to do is not 3s, it's actually 2s. Okay, but then we do have another orbital yang p ni. Okay, so I'm going to do, okay, Miss nak copy balik. Tapi dalam case ni, kita nak draw p orbital. Okay, so kalau p orbital, if you still remember, dia adalah dumbbell shape. So kalau dumbbell shape, dia macam ni lah. So for p orbital, we have 3 choices. Be it, kita boleh buat jadi px, boleh, py boleh, pz pun boleh juga. Okay, tapi dalam kes ni Miss nak buat py lah. Okay, so py. So sebenarnya tak kisah pun mana-mana. Cantik pula ni. Okay, so py. So next one I'm going to draw is actually make sure kita shadekan dia. Okay, and then label lah. So what is this? This is actually our 2py. Okay, depends. X boleh, Y boleh, Z boleh. At least draw one of the, tak perlu, there's no need for you to draw 3 of the p orbital. Tak kisah pun. Tapi at least selamatnya buatlah 1. Okay. So question C dengan D, I believe you could do it yourself. Cuma yang question D ni, remember, the positive ke negative ni, it's actually based on the atom punya arrangement tu nak achieve octet. So that's for question 1 and now let's look for example number 3. So sulfur is an element in period 3. But this case around, dia tak ada bagi number of protons, so we have to look based on the list of constants. So sulfur kita, kat sini. Sulfur is here. Sulfur, which is S, number of proton dia 16. So dekat sini, Z kita is 16 lah. So write the electronic configuration. So electronic configuration kita, so again, 16 sulfur, so 1s2, 2s2, 2p6, so it's 10, 3s2, 3p4. Okay, so that's the electronic configuration. Next, the question asks, draw its orbital diagram. Okay, so orbital shape is this part. And this is what we call orbital shape. Orbital diagram yang mana? Yang macam ni lah. Yang ni. Okay, so dekat sini, bisa buat awal-awal lah. Okay, so this is actually our sulfur 16s. Okay, so 1s2, make sure write down jaraknya between each of the orbital tu. Okay, and then make sure it's pair up. Okay, for this example yang 3p4 ni, what we're going to do is actually we're going to fill it singly first before pairing occur. So dia adalah 3p4 kan, so jadi 1, 2, 3, then barulah 4. So dia jadi 3p4. Macam ni lah, Miss buat je lah lagi sekali. 1, 2, 3, 4. Okay. Next question. How many unpaired electron does it have? So kita tengok based on the orbital diagram, how many electron yang singly paired. So yang ni dah pairing, yang ni semua dah paired up. This one pun. Okay, this one we only have 1, 2. So how many unpaired electron? Kita bagi tahu lah. There's 2 unpaired electrons. Okay. So question number 4, I believe you could try yourself. So sama sahajalah dengan ni. Cuma make sure the number of proton tu look upon your list of constant. Now let's look for question number 5. Okay, so for question number 5, the following sets of quantum numbers represent the 3 outermost electrons of element C. So the 3 outermost electron. So kita tengok when n equal to 2, L equal to 1. So kalau L equal to 1, so maknanya it's actually p orbital. So when n equal to 2, so maknanya I know here is actually 2p. So dekat sini pun here kita ada 2p juga. 2p. Nah, yang ni pun when n equal to 2, L equal to 1. So masih lagi 2p. Ni. 2p. Okay. Remember, L equal to 0 dia adalah s orbital, L equal to 1 dia adalah p orbital. Okay, so it means that how many p yang kita ada kat luar ni? Kita ada 3. So here bila kita total up semua ni, we do have 2p3. Okay, so that's the outermost electron lah. Okay, right now let's look. What is the maximum number of orbital that exists in the shell n equal to 2? Okay, so yang ini, just remember kan? Ingat je lah. When n equal to 2, sebenarnya L could be equal to 0 ataupun L could also be equal to 1. Okay, so here is actually our 2s. This is actually our 2p. Okay, maximum number of orbital. So number of orbital ni sebenarnya number of your box ataupun number of your platform. Apa yang box? Apa yang platform ni, Miss? Ni maksud Miss yang ni lah. This part. Ni box ni maknanya kira kan. Macam ni. Ini satu box. 1 box, 2 box, 3 box. Maknanya ada 3 orbital pada 2p. Pada 2s ada only 1 orbital. Macam itulah. Okay, so kita tengok balik pada question itself. Okay, so what is the maximum number? So maximum number, so bukan yang dah diisi, tapi maximum number yang boleh when n equal to 2. So when n equal to 2, sebenarnya yang first yang kita boleh ada is actually our 2s kan, 2s. Lepas tu after 2s we could have 2p. 2p remember dia ada 3. Okay, alamak saya ingat pula. Okay, kenapa dia ada 3? Okay, kita kena, so tu cakap soalan ni dia combine sikit 2.2. Sebab when L equal to 1, M could be negative 1, 0, positive 1. So it means it has 3 possible kan. Number orientation kita 3. So that's why lah kita ada PX, PY, PZ. Actually dia sebenarnya sama je lah. Okay, so orbital kita, tapi when we draw our orbital diagram, we don't have to label it as PX, PY, PZ. We're just going to label it as 2P only. Okay, so what is the maximum number? So kita kira lah 1, 2, 3, 4. So we have 4 orbitals. This is the maximum number. The next is actually write down the electronic configuration of element C. Okay, so dia bagi hint dekat sini, the outermost represent the 3 outermost electron. So from here we know it's 2p3. Okay, but then before we fill up 2p3, based on our ball, we have to fill up the energy in the electron in terms of increasing energy. So first start dia adalah 1s2. After that 2s2, barulah kita ada 2p. Tapi dalam kes ni, how many electron in 2p orbital kita is actually 3. So dia jadi dari sini 2p3. Okay, next, draw the shapes of orbital for the valence electron. Okay, again, valence electron is our outermost electron, which is our highest n. Ni senang kalau, okay, tak apa, nanti saya explain lagi. Okay, so yang ini shape of orbital, yang kita kena draw lah. Yang S spherical, P dumbbell, D cloverleaf. Okay, tapi dalam kes ni n tu n equal to 2, n equal to 2 ada S dengan P kan. So yang ini P sila ni. Okay, so possibility dia ini. So 2py. Okay, so that is actually question solution for question number 3. Okay, so question number 5C. Okay, question number 6 ni, yang ini sikit je misolong, which is the first one. Okay, the following sets of quantum number represent the 3 outermost electron of element D. So when n equal to 3, L equal to 0. So it means is 3s. Ini pun sama 3s sebab L dia is equal to 0. But this time around, n equal to 3, L equal to 1. So here is actually 3p. So what does it mean here is actually the outermost electron is 3s2, 3p1. Okay. So soalan ni actually sebenarnya dia dah bagi hint dah dekat kamu. Kamu jangan fikir lebih macam mana kita nak tahu outermost ni. Sebenarnya mana Miss tahu ada 3p ada 1 je. Kan boleh ada sampai 6 kan. Tapi dah question ni bagi 1, so 1 je lah. Macam tu je. Yang ini question ni tak payah fikir banyak. Maksud dia apa yang dia bagi, kita ambil je, terima sahaja. So that's for question 6. Yang ni, yang ABC ni, I believe you could do it yourself. Okay, the last question that we're going to look at is question number 8. Question number 7 tu boleh buat sendiri. Okay, question number 8 here. Given the set of quantum number for 2 electrons with the highest energy electron in atom F. So kat sini tengok n is actually equal to 3, L kita equal to 2. So apa tu? Okay, kalau L equal to 0, dia adalah S orbital. When L equal to 1, dia adalah P orbital. When L equal to 2, dia adalah D orbital. D. So what does it mean here? It is actually here is 3D. Ni pun 3D. So the highest energy electron. So maknanya kita akan ambil, we're gonna terus assume, maknanya the outermost electron dia adalah 3D2. Okay. Maknanya kat sini. Okay, so write the electronic configuration of F. Okay, so sebelum kita isi 3D, apa yang kita kena isi dulu? 1s2, 2s2, 2p6, 3s2, 3p6, 3... Pasal apa? Okay, yang ini. Okay, based upon yang ini, it's actually our transition element kan? Okay. Remember, before we fill up our 3D orbital, kita akan fill up our 4s dahulu. When 4s is filled, then we're going to fill up 3D10. So sebenarnya 3D orbital. So it means that before kita isi 3D orbital ni, kita kenalah isi kita punya 4s2 dulu. 4s2 baru 3D2. Okay. Okay, boleh. Sebab kalau contohnya, kalau 3D in the order of arrangement of above tu, memanglah banyaknya kita ingat turutan N kita kan, 1s, 2s, 2p, 3s, 3p. Tu sebenarnya kebetulan sama saja dengan the order of increasing energy. So for 3D orbital, for the 3D orbital to be filled, kita mesti fill up 4s dahulu. So that's why the 4s to 3D tu. So what I'm going to do now, so yang ini betul, tapi kalau nak lagi tepat, kita arrangekan lah. Yang ini ataupun Miss buatlah ini. Ni sama juga. Lagi tepat lagi kalau kita nak buat 3p6, 3d2, 4s, 2k. Next, determine the type of orbitals based on the quantum number. Okay, so orbital ni S, P ke D? Kita tahu dia D, tapi kita lagi spesifik lagi, kita tahu it's actually adalah 3D orbital sebab n equal to 3 kan? So 3D orbital. Okay, next question. Draw the shape of orbital occupied by the electrons with the highest principal quantum number in F. So highest principal quantum number dalam kes ni is actually n equal to 4. Kan? Bukan n equal to 3. Sebab 4 kan ada lagi. So n equal to 4. So I'm gonna draw my S orbital. Tapi jangan lupa labelkanlah. Labelkan. It's not 2s. It's actually our 4s orbital. Okay, so that's for question number 8. The last one. Okay, so that's the end of chapter 2. Okay, yay!